Good morning, everybody.
Good morning, Miss Bryant.
So today we have a special guest with us. We have Mr. Mather, and he's going to be with us for the quarter. So I wanted to introduce him. He is a good friend of mine, and we've worked together for quite a few years now on different projects. And he's been here in the past working with us on the TinkerYard. So I'm going to let him tell you a little bit about that project, what we've done so far.
So the TinkerYard is something that's been completely designed by students and built by students. It's just outside the windows of the engineering lab. There's lots of things to do out there that we call design thinking experiments. Design thinking stations that let us try out different ways of learning with materials. Now, I'm a sculptor. I make big public art projects. But here at Drew Charter School, we make sure that whatever those look like, they look good, they look interesting, but there's also something to do. There's also something that you can change, that you can build, that you can take off and add on. And that's how we've come up with the plans for this TinkerYard. We're not the only cool thing happening outside these windows, though, with the TinkerYard. There's also a raised bed garden program that's been coming along and doing really well. We're looking for a way that you can design something that helps to connect what happens in the TinkerYard and what happens in the raised bed gardens. And Miss Bryant has an idea for you to work on. I'm a teaching artist here in Georgia. I've been a teaching artist for the Georgia Council for the Arts for many years, as well as for some other programs, including out of the Woodruff Art Center. Being a teaching artist is a role where people might think that we're art teachers because it sounds similar, but we are actually co-teachers with educators.
Raise your hand if you are part of the garden program or you have worked in the garden here at the school before. Excellent. All right, show me you're ready. Okay, so what I need to have happen today is some of you guys are going to be our experts because you've worked in the garden before. We actually are going to be working on a project to help our gardeners. One of the things that I noticed and our master gardener, Miss Gomes, noticed is that all of the garden supplies end up spread out all over the TinkerYard. And one of the things that I would like to provide for her is a storage location for those garden supplies. And she would like that very, very much. She also noted that the garden program actually needed a place to work. So because they are all over the place using different parts of the TinkerYard to work on, and it's not actually, we're in the way of each other. So she has suggested a site, but I've put together for you guys our brief. And remember, the brief is what we start with. Whenever you're a designer, your client comes to you with an assignment, and that assignment tells you what things you need to look at and what things you need to pay attention to. Whenever I introduce a lesson to students, I always bring it to the group in a similar way that they would do in industry. We have industry partners that we work with here at Drew that are part of our advisory board. And in talking with them, we get real-world scenarios at times, and then I ask them how they might approach that situation or what it looks like in industry. And so a lot of those aspects then translate into the classroom with students, so they're getting some exposure to how it really works. As we were talking, Cooper, to Ms. Gomes, as I was talking with her, some things that came out of the conversation include these things. So I would like for Linda, would you read the first sentence in our brief?
Drew Charter School has a working garden for students to utilize during the day and after school.
Excellent, thank you. And then the next sentence for me, Axum, would you get that?
Each season, some old plants are removed and new plants are added.
Very good. The next sentence for me, Maya.
Tools are used for this, and a table would be useful for preparing the plants.
Okay. Sam, would you get the next sentence for me, please?
What could we make to store the tools and provide a workspace for the gardeners?
Very good. So here's some questions that I had and Ms. Gomes had as we were talking about the project. So would you read the first question, Avery?
What recycled materials could we use?
And that's a big part of the TinkerYard already. We have a lot of things that come from recycled materials out there. So in looking around the school, what things might we be able to use? So who can tell me something that you know we have a lot of that we could probably use for our, and I'll give you a hint, there's a picture up there one up on the board. Let's see here, Ellis.
Wait. Wood?
Yeah, wood. There's a lot of this type of wood. What is that wood usually configured in, Tyler? Pallets, yes. At the beginning of the school year, every year we get a bunch of supplies delivered like paper and things like that, and they come on pallets. This would be something that we could use that would normally go to the landfill, and we could keep it out of the landfill and use it for good purpose. All right, the next question on there, Biko.
What can we do to make it user-friendly and durable?
Yes. Does anybody know what that word durable means? Durable. Sam, do you want to make a guess?
I think it means if it's like it stays there, it doesn't fall down.
Exactly. It doesn't fall down. It stays strong year after year. Raise your hand if you want the project to last for longer than just this year. I'm glad I see a lot of hands up because that's the goal, guys. It needs to last for longer than just this year. And then the last question, Zelda.
How will it be unique?
What's the word unique mean? Noah. I mean, not Noah, excuse me, Nia.
Unique means like cool and pretty.
Yeah, cool and different, pretty looking, interesting looking. Go ahead.
Original.
Original, that's a good synonym. Okay, the last one, I'm going to reiterate this to you because I want to make sure everybody hears this. Your goal is to create a workspace/tool storage solution that is user-friendly, durable, and relates to the parts already in the TinkerYard. Is that everybody give me a thumbs up if you understand what we're doing. Excellent. Show me that you're ready. Perfect. When they get the brief, there are some questions that are initially there. Then part of the research process is not just going to the computer, but asking members of the community who might serve as a resource. All right, so our next activity, we are going to connect with one of our professionals who's going to be helping us on this project. Remember, we talked about Ms. Gomes and her being a master gardener. Well, I've asked her to come in and talk to you guys, but in advance of her doing that, we're going to get her some questions, and I'm going to send them to her in our email. So I'm going to ask you guys to tell me some questions that you might have before we build our garden bench that would help us know how to build it so that it would be exactly what the gardeners need. So Maya, what's your first question?
Is there any particular color?
Okay. Is there a particular color? Okay, thank you, Maya. Myron.
How will you put the garden bench into the ground?
Okay, so how should it be connected to the ground? Okay. Thank you, Myron. All right, let's see here. Zelda?
What length should it be?
Ah, that's a very good question. What length should it be? Let's see here, next line. What length should it be? Very good. You guys are coming up with some great questions. Avery?
How tall should it be?
How tall should it be? Very good. How tall? Okay. Tyler, real nice and loud for me.
How do we keep the tools in?
Oh, so how do we keep the tools stored in it? Okay. Okay, all right. Susanna, really loud.
What shape should it be?
I like that question. What shape? When we're talking about sculpture, Mr. Mather would be happy about that question. What shape should the bench have? Okay. All right. Let's see here. Biko, real nice and loud for me.
How many hinges should we have?
Oh, should we have? I have a question before that. Hinges. What do we have to need hinges?
Doors.
Excellent. Now, do we know whether we even want doors?
No.
No. So maybe we need to ask that. What should the question be?
Should we have doors and then hinges?
Yeah, I think so. Let's ask that. Would you like doors, and should it have hinges? Let's see here. Nia.
What material should it be made out of?
That's an excellent question. You guys are coming up with some great questions. What materials should it be made out of? Okay. They interviewed one of our master gardener, and that was certainly a resource, but they also needed to even see what a garden bench looked like because many of them had never encountered that term before. And so in the search process, then they can get a visual to go along with it, see what some of the features might be, and then oftentimes what happens in that situation is they start to see, oh, there might be even more questions that I have after seeing and experiencing it in a different way. Today, Mr. Mather is here with us to give us some help with our idea generation. And remember, idea generation is when you take all your brainstorming ideas and then you put it into a drawing that other people can understand. And one of the things that you do when you do a drawing to help other people understand is you make it so that it looks 3D. And Mr. Mather's here today going to talk about that a little bit.
Yeah. So I make public art projects with people all over Georgia, and sometimes they have great ideas and they come up to me and they want to tell me their great ideas. Mr. Mather, what if the sculpture kind of had this part that came over here and then underneath, and they start talking to me like that, and I say, I can tell you have a great idea. Please draw it down, because words will only take us that far, and we're going to be better communicators about this kind of thinking if we draw. So I have to get people drawing who aren't necessarily always used to drawing, but here's how we do it. We talk about drawing as something our bodies know how to do. Now, our bodies sometimes need to get all together with our brains so that we can work together and be good designers, good problem solvers. Let's do just a quick warm-up for our bodies. Cross your ankles underneath your chair, or out in front of your chair, under the table, and then put your arms up in front of you with your thumbs pointed at the floor. And then you go a little bit stiff, then one hand goes up a little higher, and then over, and then back down. Thumbs are still pointed down at the floor or the table. You get a little stretch on the back of your forearms when you press your hands together and grab on tight. Pull inside out, and that's more comfortable. One finger springs free, and you put that on the side of your neck very lightly. We're going to breathe 3 times with deep breaths, but with very little sound, no sound. 3 breaths. As a design coach, I emphasize muscle memory, the physicality of drawing and designing. A lot of good design work can be stuck in people's heads, and I coach all age groups, so I've seen it happen a lot with adults, somewhat with high school kids, less so with elementary school kids. They're pretty free, they're pretty loose with their drawings. But one thing I like to do as a warm-up is part of a vocabulary of movements, very simple movements that are referred to as brain gym. And this has to do with crossing the line of symmetry of your body. And it turns out, and they've done many studies of this, that when you do body movements that cross the line of symmetry of the body, it activates both hemispheres of the brain. And this elevates problem-solving abilities. So asking them to design, well, designing is problem-solving. So I find that it does a couple of things. One is it makes them work more fluidly. The other is it creates focus. So sometimes I ask people to do that when it's time to draw and design. I have my juggling clubs here today, and I know you guys know I'm a sculptor, so sometimes when I pull out juggling clubs, people look at me a little confused. Mr. Mather, you're a visual artist, you're not a performing artist. Why would you have juggling clubs? But when I juggle, I remind myself that juggling is like drawing, and drawing is like juggling. They are both things that my body knows how to do, and I do my best at both things when I'm most relaxed in my body. So the muscle memory is what I'm talking about. Say muscle memory for me.
Muscle memory.
Our muscles remember things very well. They say when you learn to ride a bicycle, you never forget how. We forget lots of things. How come we don't forget how to ride a bicycle? Because you don't learn it up here, you learn it in your body. But we're going to give you some sketch paper, and we're going to do a drawing, and neatness does not really matter for this. There's a time for drawing neatly. This is not one of those times. We're going to draw very loose and relaxed. You ready? Yeah. Okay, so we need to get you some paper and some pencils.
All right, what I would like for you to do today, everybody say the word perspective.
Perspective.
Perspective is a way of seeing things in 3D. Now, when you are drawing something, why might you want to see your idea in 3D? Why would that be a helpful thing? Why would that be a helpful thing? Tyra, speak real loud so I can hear you.
So we can know, we will probably do some pictures like right there, because we always do that so we can focus what the picture's gonna look like.
Okay, so we can really understand what it's going to look like. Boys and girls, what we're getting ready to do next is Mr. Mather's going to come up, and the two of us are going to talk about how to best show your idea in 3 dimensions, in 3D. And we're going to use the tools of perspective. And I want you just to relax. Don't think about your idea yet, because we have some vocabulary and some things to share with you. And then we'll move into getting that idea down on paper. Okay? So Mr. Mather, come on back up.
Okay. So we gave you a piece of paper that's not a blank piece of paper. It actually has a very softly printed photo of the part of the school where this garden bench project that you're thinking of ideas for will be built. So I'm what's called a site sculptor, which means I don't go off into a shop and make a sculpture and then only later figure out where it can go. We always start with the where can it go question first, which is why you don't have blank paper. You have a piece of paper that shows a particular part of school. But before we're going to get into putting your designs on that side, take your piece of paper, I've got it enlarged with the document camera, and flip it upside down for a minute. Okay. I'm going to use one of the digital markers on the smartboard, and I'm going to draw a box, just a simple rectangle, and I'd like you to do this too. So get a pencil, any color will do, any color at all, doesn't matter. Probably a darker color would be good. And I want you to draw a rectangle, and it doesn't matter about straight lines. We're being relaxed, and if your lines come out crooked, that's okay. For this, that's okay. I want you to draw a large rectangle on your paper, and mine doesn't look perfectly straight, but I like it just fine. Okay. We call this a 2D shape, a flat rectangle, but we want to think about 3D ideas like Miss Bryant just said. When I say that art is 2D or 3D, what does the D stand for? Tell me. I see all the hands up. Excellent. 2-dimensional or 3-dimensional. Now I'm going to give you another D word that works just as well for what we're doing, and that word is direction. 2 directions or 3 directions. Right now, this rectangle is only moving in 2 directions, up and down and side to side. But I'm going to stop calling it a rectangle, and I'm going to start calling it a window. And if it's a window, we can pretend we're looking through the window, and we can pretend that we're anywhere we want to be. So let's look out this window and pretend we're not even in Atlanta anymore. We might be in open countryside somewhere. Take your pencil and split your view looking out the window with a line across the middle. And we're going to say from now on, everything above that line is sky, and everything below that line is the earth. We have a name for the imaginary line between earth and sky, and it begins with an H, and I see some hands up. What is it? Yes, tell me. Yes?
The horizon line.
Horizon line is what I was hoping someone would say. So yes, that is a horizon line, which is where we get the word horizontal. When things are flat or level, they're like echoes of the original horizon itself. Now, going back into space in our imaginations, out the window, traveling towards the far horizon, I want you to put a dot somewhere on the horizon line, big enough that you can see it. And now we're going to make some lines that come towards us in space out of that dot. These do not have to be solid lines. They can be broken lines, like dash, 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 or like a dotted line. Put your pencil on the dot, and here we come with some broken lines that are coming down below the horizon, headed towards the bottom of the window. And then when they come to the bottom of the window box, they keep going. We just don't see them anymore. They've gone out of view past our window frame. Back to the dot. And again we go down, down, down with a broken line.
Now, I want to make sure while they're drawing that, does anybody know what that dot, the starting place for all our dashed lines, Myron, what is that called?
It's called the VP line.
The VP.
Excellent.
Now, who knows what the VP stands for? Who knows what the VP stands for? Go ahead, Sam, real nice and loud.
The vanishing point.
Very good. The
Very good.
vanishing point. Very good.
Okay, one more. Let's do one more. Back to the dot with your pencil. This time, let's go above the horizon into the sky. A broken line that goes up, 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 almost like an airplane or a helicopter flying towards us, getting closer and closer, and then it flies past us over our left shoulder. Okay, so these broken lines are moving in a third direction. When we only had a flat 2D shape, we said it was moving in two directions, up and down and side to side. Well, side to side movement, sometimes we call that movement X movement. Put a small X underneath your window and make arrows that say side to side would be X movement. Up and down, sometimes we say that's small Y movement.
And boys and girls, you'll see this again when you take geometry later on when you're like in high school.
Yes.
You'll see X and Y. Axis is what it's called. You also see this in 3D printing. Next year when you take 3D printing with me, we'll talk a lot about X and Y axis.
That's two directions.
Yes.
Now, I'll bet you know what letter we use for the third direction. X, Y, and? Z. These are Z lines. You can put a little Z right next to them. And this time the arrows say towards the horizon, towards the vanishing point, or towards us. That's that kind of movement, Z movement. And that's what is also called perspective. Ms. Bryant used that word a minute ago. Big word, P-E-R. S-P-E-C-T-I-V-E. That's kind of a $10 word, perspective, but it's got a very simple meaning. It just means that's what I see. I look out the window, that's my view. That's what I see, that's my perspective. So we call these Z lines also perspective lines because they lead our eye back into space. Let's do just one quick warm-up thing that gets us ready to go to the flip side photo. When I look at these Z lines, I see that the closer they get to the horizon, the closer they get to each other. Everything is converging. The easiest, most relaxing thing I know for a warm-up drawing is shrinking clouds. Because if everything's converging, well, another word for converging is just shrinking. Let's make some freehand, very relaxed looking clouds. The only thing I would say is not ball-like clouds, but sort of stretched out like sunset clouds. But as they drop down in the sky, they get skinnier and smaller and skinnier and smaller. So the first one is up high. Let's freehand a cloud up there, but sort of stretch it out, sort of a hot dog shaped cloud. Underneath it, a very similar cloud, but it's skinnier and flatter. And underneath it, an even skinnier one. This one's so skinny it hardly looks like a cloud. It looks like a funny squiggle moving across the sky.
Do you guys notice how the clouds are getting skinnier and skinnier? They're not as big and tall, if you will. So the Y is not as big. The Y is shrinking.
Now, we're not trying to make a pretty picture here. We're just
No.
getting warmed up. So that's why I said neatness is not that important right now. It's about the idea of space. We're getting warmed up to make sure we can communicate
And
about
Mr.
space.
Mather, I'm going to capture this image so we have it for our data bank. Okay?
Great. Okay, very good. Okay, so I'm going to erase my warm-up and we're going to flip our photos over now.
You guys can flip your photo over, please.
With our sketch paper turned back over to the photo side, having done our warm-up, I think it's helpful because right away I can see Z lines on our photo. What are those Z lines that are starting back in space and coming towards us in this photo? What are those lines describing? Yes, tell me.
The sidewalk?
She said the edges of the sidewalk. Everybody recognize those? Yeah. Yes, that's just the edges of the sidewalk. So we had railroad tracks in our warm-up. You could do a road. This is just the sidewalk that runs by the raised bed gardens outside and then the area near the TinkerYard over here. Now, Miss Bryant has sketched in something to help us with generating ideas for the garden bench, and that is a pallet. Not only has she drawn a pallet over here, but she's left it so it's kind of floating up in midair so that you guys can give it legs. Now, let me use one of the markers again. Everybody see the pallet? Okay, so I know if I'm going to put a leg on one corner of the pallet, it's going to be a larger, thicker leg when it's up close, but if this is closer to the vanishing point dot, then that's going to be smaller. Just like our clouds were shrinking, so will our legs be shrinking. So this leg will be skinnier and shorter because it's further away in space.
Now, Mr. Mather,
Ms. Bryant.
do all of the benches that these guys draw, do they have to have legs that look just like that?
No, I'm just doing a quick demonstration. Your legs could have interesting sculptural shapes or patterns.
And I want you guys to think a little bit about what shapes you see out in the TinkerYard. As you're designing the legs, as you're designing the components of your bench, I want you to think about some of the shapes that you already see and some of the lines, the type of lines that you see out there. Who can name for me a shape that you see frequently when you go out to the TinkerYard? What's a shape that you often see? Avery?
Squiggly lines.
Squiggly lines, okay. Josh?
Rectangles.
Rectangles, okay. Free?
Triangles.
Triangles, okay. Those are good. Those are types of shapes. Now we got a type of line in there too. Who can name for me another type of line that you see a lot of? Zelda?
Horizontal.
Horizontal lines, very good. Alexandria?
A 3D line.
3D line. What do you mean by that?
The colored sticks are kind of like 3D lines because they're not actually straight. They have they're kind of bigger in their line.
Oh, the ones
Okay.
that have some sculptural shape to them that we made for the TinkerYard, yes.
Okay. Elias?
Parallel lines.
Parallel lines, yeah. So you guys I'm asking you these questions to kind of jog your memory a little bit about the types of lines and shapes that you actually see in the TinkerYard. And I'm going to let Mr. Mather, would you maybe show them how we could incorporate some of those?
Right. So if we know we have some material that's lined up for this project in the form of these existing pallets, what can we do to take advantage of those surfaces and then build up some of the other parts of a good garden bench and make it look fun like the TinkerYard looks like so much fun?
And then
So
there's one more component that
Yes,
we need
please.
to think about. We need
Yes.
to also think about our master gardener. Before we draw, we need to think about some of the things that she asked for. She asked us for, remember back to our research where we emailed her and then she came in and responded? I want you to think back to her responses. She needs a place to put her shovels. She needs a place, some shelves maybe, some locking doors maybe, or some way to secure the tools in there. So
Yes.
remember to think about all of those things too. You want to make it look nice, but it also has to be functional. It has to work.
Right. So let's take advantage of how much space there is above a pallet like that and make sure that we enclose some of that space so she can keep her tools inside. So this is what I want you to do, and you can switch colors, maybe use at least 2 different colors out of your pencil box or pencil bin, and let's start to add some shapes that create space to put tools in, but also have some of the TinkerYard shapes that we know and love. And I just heard people saying those parallel lines, those sculptural lines.
Triangles.
That's right, we have
rectangles.
triangular shapes. There's even
Yes.
some wheels out there, some curves. So let's just start to build this.
Okay.
And you guys can all get started right now.
Yes, go ahead and start.
The things that come out of Courtney Bryant's engineering lab are meant for real-world applications. And we want them to design things that don't just sit on the table here in isolation. That, part of the ways that Courtney and I think connect on our thinking is that we both think of work in context. So I'm what's called a site sculptor, which means I don't have a studio practice. I don't create sculptures apart from community. I only work in partnership with community. So we had these photos of a very particular part of the school environment that became the sketch paper for the students. And for them to execute a design for this garden bench project or any of the parts of the TinkerYard that look like they really belong out there, they really fit that setting and that environment, they need to be able to draw in perspective. Now this is quite ahead of schedule for where they might be introduced to perspective in another school or another setting. But for second graders to be able to take a photo of a site and understand about using the vanishing point and the perspective lines and make their drawing recede with the illusion of 3D into the photo, they're communicating more clearly about their wishes for their designs. Now I like the way that Maya is outlining her shapes and using doubled lines to show the thickness, and then she's adding a contrasting color in between her doubled lines, which makes it read really well. In perspective.
And the other thing that's cool about having the double lines is it actually gives us clues as to how to build it, because the double lines actually make it look like a piece of wood that we could cut out and actually assemble. The equilateral triangles were designed to go out in the TinkerYard and be sculptural elements for the garden bench. The garden bench is very structurally sound and does what it needs to do, but it needs to relate more to what the other elements of the TinkerYard. And the equilateral red triangles are a big part of that. So the lesson today having to do with the equilateral triangles was primarily designed to tell them how you make an equilateral triangle, and that you need to pay attention to the length of the sides and the angles themselves. That's how you get an equilateral triangle. And the next step would be then to measure out the sections, get the angles correctly positioned, and make the cuts, and then screw the pieces together. Boys and girls, what we're going to do today is we're going to talk a little bit about triangles. Raise your hand if you know what a triangle looks like. Oh, I'm so happy you know what a triangle looks like. All right, show me that you're ready. Now, Mr. Mather happens to be holding one in his hand. It's nice to work in a place where I have visuals to share with you. And this is one that we have made in advance of our conversation today. And it's a special type of triangle. But first, let's talk about some qualities of triangles before we get started. Who can tell me, Josh, how many sides are there to a triangle? 3. Okay, I'm glad we know that. Now, you may not know, there's some information about triangles that you guys aren't supposed to know yet, but I'm going to give you some secrets about them. Okay? I'm going to give you some secrets. I'm going to let you in on some of my secrets, because guess what? Yes, I see I've got a poster about triangles in here. You guys didn't know this, but this is also math class, right? Okay. Yep. We learn math in here too. STEAM is by nature integrated, and the students benefit when all of the parts play nicely together. In the real world, at least my advisory board members tell me that in the real world, when you go to do a project, if you're an architect or you're a shoe designer and you're designing something, you don't say, oh, I'm going to do the math part today. When you get to the measurement portion for your shoe, you have to do the math part, you know, and all the parts come together, and it's not segmented out. It's very, for lack of a better word, integrated. And that's what I want our students to see, that they're learning all of the things for a reason, and they're all going together to produce something, create something, to change the world, to make it a better place. Basically, we're learning a special type of math called geometry. I did not learn geometry until I was in 8th or 9th grade, and everybody made it into something really, really like I was going to be scared of, but I loved it. I absolutely loved it. And one of the things I loved about it is it was the math that was the easiest for me to actually put my hands on and understand. So I really, really liked it. But there are some things that you have to understand even when you can put your hands on the math. There's some things that you just have to accept. And one of those things is that triangles have angles. And it's actually in the word what's the second part? Angle. Okay. Now, what does tri mean? Biko? 3.
All right, Biko.
Okay. So how many angles are there? 3. Exactly. So we have 3 angles, and Joshua already told us there are 3 sides. Now, I want to ask you some questions here. This triangle here, I'm going to put here, and actually I'm going to zoom out just a little bit so we can see more of our, may have to move us up just a little bit here.
That helps.
Okay, and center us back up a little bit. Okay, so we've got this triangle here, and one of the things about triangles is not all triangles look exactly the same. It's another reason why I love geometry, is because there's a lot of, let's change colors here. There's a lot of room for differences in the way that they look. Some can be long and skinny. okay? They can have different looks to them, okay? Now, why is this one different from this one, other than the fact that it's long and skinny? What's different about it? Tyler, real nice and loud.
It's longer and bigger.
It's longer? Okay, so can you give me a little bit more information? What parts of it are longer?
The two sides are longer than the bottom one's short.
That's exactly right. That's exactly right. Now, two of the sides are really, really long and one of them is short. So that's what causes that triangle to look a little bit different, okay? Now, there's also something that you guys aren't supposed to know quite about yet, and that's a word I didn't learn until I was a lot older than you, and that's a word called angles. And those are the measurements in between the lines. So everybody make an alligator mouth like that. You have just made an angle. Where your head is, nod your head, that's the angle, okay? Where your head is bobbing up and down, that's your angle. All right, show me that you're ready. So you have an understanding now of how many sides are in a triangle. You have an understanding of what an angle is. It's that space. It's a measurement of space. And Mr. Mather and I are here today to talk about a special type of triangle that we're going to use in the garden bench, a special type of triangle that we're going to use in the garden bench to actually add to, because we've already used it in the TinkerYard a little bit in other places with other classes. So we want to make sure that we're using that similar repetitive shape again, okay? So you want to pick up?
Yeah, I do, because one thing I love about being in Miss Bryant's lab is that she has a lot of good tools. She has power tools, she has bench tools, sanders, drill press, bandsaw, and that's what I need to know how to use to make these kinds of triangles. So, Miss Bryant, do you have a tool here in your lab that helps us to find angles and make angles?
I do. Has anybody ever seen a tool like this before? I'm glad that you've seen a tool like this before. Does anybody know what this tool does? What does this tool do? Ellis, what does it do?
It kind of helps you where you need to see where you need to cut and...
Yes, it does. It helps us see where we need to cut and stuff, okay? So specifically, do you notice how it has an arm? It does kind of like what you were doing. Do that with me. Does that, okay? It does the same thing. This little arm, and if you notice, look at the little center part here. What does that represent? What does that represent? That little center part right here, there's a little hole in it. I'm going to put it up on the screen so you can see it.
Put
I'm
the
gonna
triangle
use
back?
my pink one.
Okay.
All right, so there's a little hole right there in the center. And I'll give you a hint. Your head, when it was bobbing up and down, you notice your head is the exact same shape. Okay? What does that represent? What does that represent? Elias?
Angles.
The angle, that's right, that's right. So this right here, that little space in there tells us what the angle is. Does everybody see that tiny little pink dot on there? Yeah. That is an arrow that points to a number on here. And that number, and we can zoom in so that you can see it a little bit better, but that number tells us how big the angle is. Now there's something else. I'm full of nuggets today that you're not supposed to know. And this one actually shows the numbers a little bit better.
Oh, it will. You're right.
Okay, so the numbers are on here. And there's something that you need to know, and I actually may need some help with this in just a second. So I want you to watch for me, okay? Watch, show me that you're ready real quick. Because we're going to do some body movement in just a second. Show me that you're ready, please. Thank you. All right, so what we are going to do is we're going to learn about how many degrees are in a triangle, okay? You've heard me when you're in line. We're lined up in the hallway and I say turn 180 degrees. I had to explain to you what that means. What does that mean, Joshua, when I say turn 180 degrees? Turn around, okay? Now, I'm going to blow your mind here for a second. All triangles, it doesn't matter what they look like, all of them have 180 degrees. Now, it doesn't mean they turn around in space. It means that when I add up this angle right here with this angle right here, ooh, goodness, okay, and this angle, if I add up all three of those, it will equal 180. So I'm gonna show that physically real quick here. So this is A, we're gonna call it A, this is B, and this is C, okay? If I add up angle A plus angle B plus angle C, it's gonna equal what? What's it gonna equal, Susanna?
180.
Yes, ma'am, 180
All right, Susanna.
every single time. Now, and that's something that you just have to know. You just have to learn that. Now, I've got a hypothetical situation for you. Hypothetical means if this happens, what's going to happen? Okay, so let's say that angle A is 10 degrees. Angle B, and we put a little circle beside it, that means degrees. Okay, angle B is 90 degrees. What is angle C if it is 180? I need to know who my genius folk are in here. Who are my genius folks? Myron, what do you think the answer is?
60.
60, okay. That's a good guess. On Georgia Milestones, you have to explain your answer in your math portion. So could you give me why you think that? Explain to me in a couple sentences.
Because I think 10 plus 90 plus 60 equals 180.
Okay, his thinking, his logic is correct. What he's doing in his head is he's adding that together plus that to get 180. The problem is his math's not quite right. So if he was in my class, I would have given him half points for that answer because his logic is right, but we need to get our math right. So let's see here. Maya, help me out with the math.
80.
80. Now,
Because 90 plus 10 is 100, and 180 is 100 plus 80.
that's exactly right. So what you guys just did, you may have heard this complicated math before, is called algebra. You just did algebra. Give yourself a pat on the back. The level of rigor for the lesson today is something that you probably would find in a high school geometry class or an algebra class in terms of the type of math that was involved and the fact that it was real world makes the kids want to learn it. If they know that it is going to be used for something and that they need to know this math skill in particular, it makes it a more powerful, there's nothing more motivating than knowing that you have to know this math thing before you get to use this power saw to cut this thing out. And I find that by and large, students will learn measurement, they'll learn fractions, they'll learn geometry, they'll learn algebra, just so that they get to do this real world thing. Show me that you're ready. Now, we're going to talk about why you need to know this, because there is a reason why you need to know this. Okay, so this triangle here, anybody notice something about all the sides on this triangle? What's unique about this triangle, and it's very different from this one? What's Nia? Go ahead, darling.
They all have the same length on each side.
That's right. Now, if a triangle has all the same length here, what can we tell is going on about the angles? Okay, what can we tell about the angles? Sam?
All the angles are the same.
That's right. All the angles are the same also.
Good, Sam.
That is very good. Now, Mr. Mather, what's a triangle called where all of them are the same? Academic rigor is very important to this program and to the curriculum as a whole here. I've done a lot of work with vertical alignment and making sure that content-wise we are where we need to be for each grade level in terms of looking at what their standards that they're covering in first grade, looking at the standards that they're covering in math, science, social studies, in language arts, all of the different standards, and making sure that I'm helping with those other content areas in this particular class so that it's not done in isolation, and the kids can then see the ways that the standards that they're learning in science class are actually applied here. And I think that that's important in terms of, once again, the kids seeing the real world connections, but also in terms of them seeing value in what they're learning in the classroom. Have a seat right here. Have a seat. Have a seat. Should be dry enough. Have a seat. All right, everybody, we're going to get started in the TinkerYard this morning with a couple of jobs. So again, the jobs are mulch team, and specifically where I need the mulch, remember we've talked about in the muddy areas. So if you see an area that looks like it would get people's feet a little dirty, then I need you to get the mulch in there, because that means water's collecting there, and we need to make sure that our site is nice and level, okay? There are also some other places in the TinkerYard that will collect water if it rains, so I want you to try and identify those, and you can drop some mulch there as well. We have these crescent shapes here, and the crescent shapes are going to be used at the top of the garden bench. So I will have a team helping to install those. We also have our hinges that need to be installed. So I will have a team working with the drill over there. Mr. Mather.
And you have the green cross pieces that need to be attached.
Exactly.
Outside of the metal mesh.
Exactly.
So there's a lot going on with the garden bench this morning, but still we have more people working than can crowd around that activity. So we're going to have a crew that's going to shoot some scenes for our playbook video series, which some of you have been helping to write the scripts for. So I've got a small but high quality camera that Miss Bryant bought for the engineering lab, and we'll be using that to make some scenes for these videos. We'll be shooting more of this next week too, but we're going to go down and start with the architecture station with a small crew that's going to demonstrate ideas of how to use the architecture station.
All right, so the last thing I forgot to mention is the black border over there, the garden border that was in Noah's drawing, needs to be cleaned up, and then we'll need to cut it and go ahead and tack that in place with the hammer, okay? So I will need some people up holding that, and somebody who's doing some hammering for me, okay? So there's a lot that has to go on. Very quickly, on my mulch team, I need a crew chief. So I would like for Sam, would you be crew chief on mulch, please, sir? Okay, so would you go collect the tools necessary to lead your team? It's important to give the students leadership opportunities out in the TinkerYard and elsewhere in the classroom, especially if there are areas where I may not be monitoring as closely because I am busy working with power tools or working with a small group on accomplishing a particular task. I want the students to feel like they own their section and they are going to control what happens. They know where the tools are. They know how to handle that particular task, so that they don't need me for that. And I think that that's important too, because for safety purposes as well as for giving them ownership of the project. I want to show you how to add when you get ready to change a drill bit. So let's make a spot for those so you don't have to hold them. Okay, put that under there. When you get ready to change a drill bit, a drill opens and closes its mouth right here. This is called the chuck, and it tightens and opens by turning this, okay? By turning the chuck. So you can slide your drill bit inside once the mouth is open large enough, once the chuck is open large enough, and then you can tighten it back down, okay? Now, this particular bit is for a smaller screw, like this size here, okay? The one that is in this one is for a slightly larger size screw. So when you use these screws here, which drill should you use? Yeah. Why?
There's a large screw there because those are small.
Hang on. I hear a lot of people talking at one time. Why am I using this one for the small ones? That's what you told me. Maya.
Because it's smaller.
Yeah, the bit on the end, the driver bit on the end is smaller. You're right. So this one fits this size screw, okay? And this one fits this size screw. So you know when I ask you to go get a drill, what we're looking for. Now, I have a question for you. Which size screw do you think, if we need to put this in place, and we labeled them yesterday when the class cut them, if we're going to put this in place here, Another aspect that was going on in the TinkerYard today is we were working on some of the steps to completing the garden bench, and that was adding the hinges and adding the door handles and starting to put some of the sculptural elements up on the top. This is a support piece that will help keep our bench nice and strong. Okay, so I would like for Avery, would you grab the correct drill to put in the long screw for me, please? Excellent, somebody was listening. Excellent job. All right, so now what I need for you guys to do is I need for you to line up behind Myron for me. Line up behind Myron. Everybody's gonna get a little bit of a turn, okay? All right, Myron, we're gonna jam that in there, and very quickly on this drill, you have different speeds for which you can cause the drill to go. We're going to just leave that alone, but you do need to know this is forward. The button here goes forward, and there also is the trigger right here that spins it, okay? All right, so Myron, you're going to pull the trigger for me, okay? Let's see here. Go ahead. Excellent. Nice work. I think whenever you let a student use a power tool, at first there's some safety things that you absolutely have to cover. They need to know what the different parts are called, so that when they are needing a tool from someone or needing something done to the tool and they have to ask a peer to help out with something, it gives them the vocabulary. And then the power. Vocabulary is power. So giving them the power to be able to ask for what they need is very important. Also, giving them the ability to use the tool in a structured way is important too, so that they know exactly what the tool is designed to do, they know what their body is designed, how their body is designed to use the tool, and they know then how to properly do it. It all is important for them understanding what the mission of the project is too, how that tool integrates into that. And so it's important to stop and have those conversations. Even though it takes time and class periods are usually short, it's important to go through that. If you guys would come on over here, and all right, so when we're putting them up here, some of the shapes you guys told me over there could go on like this. Some of the shapes might go on like that. Okay, are you guys paying attention, Nia? So some of the shapes might go on like that. Go ahead, Maya. I like that idea a lot. So, yeah, but maybe when they're in the middle of using them, they have a place to put them. I like that idea a lot, Maya. So I think what Maya's proposing is maybe one of them hangs out so that you could hang a plant or hang something on it. So what I would like to have happen, we need one of the longer screws. So I would like for Biko, would you go get the drill that has the longer driver bit in it over here? And Myron, would you go get one of the longer screws for me, please? Thank you. And let's go ahead and get one of these in. Avery, would you come stand right here for me, please? Climb up on the bench and come stand right here. Careful, 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 over here. It's not gonna break, it's pretty strong. I've been up on it, my knees on it. Okay, come stand closer to this side for me, please. Okay, guys, do you have it? So I want you to position this one where you think it would go. And Maya and team on the ground, would you guys tell her when you like what you see?
Yeah, that's good.
Okay. Additional group was working on directing mulch into the garden bench area and around the TinkerYard where grading or leveling of the property needed to happen. And we've had a whole lesson on why you do that and what's necessary to figure out whether you need more mulch in that area.
So the TinkerYard does invite a lot of playful exploration and experimentation. On the other hand, it's not a free-for-all zone. And because it's right outside the engineering lab windows, we get to observe how some teachers use that with their groups. And some teachers really do use it as a teaching tool, and other teachers bring their kids out there like it's simply another playground. And so we thought that we were probably at this point needing to create an instructional video series, which we're calling a playbook on video. And that way the teachers, before they take a class out there, can see some ideas of how to use the TinkerYard. And so the students, the second graders, are actually writing the script as they sort of show their favorite things and discoveries that they've made out in the TinkerYard. And we've been for a couple of weeks getting them to show us what they like to do and articulate why they do those things and how they make those choices and how they work together. We've been practicing, and Joshua and Ellis know this in particular, to use our good vocabulary. Since we're making an instructional video for all the kids, including the littler kids at school, I want you to say what you're doing as you do it. Remember this? We've been practicing. So when you get the materials from the bins, I want you to talk about why you're making the choices you're making, and then when you're building together, don't just build, but say what you're doing as you do it, because then I can get it on video.
I have to watch a lot of cooking shows.
And never say
Like a cooking show, Ellis, exactly.
And never say no. And only say yes.
Say yes.
Say yes
maybe
and.
you
We
could
like
put
that language, that's right.
there.
Okay, let me tell you when my camera is on. And begin.
My name is Joshua, and I'm gonna be on the TinkerYard show.
Hello, my name is Ellis. My advice is to have fun.
I'm Elias, and my advice is to have fun. My name's Alexandria. My advice is to have fun.
Let's see you guys do it.
So we're gonna paint this. Should we make a home?
And we're gonna make a little
teepee. Yeah, teepee.
and we're gonna put it on the little tire thing.
No, guys, make the base. We're making the base.
We're making the base like kind of the floor. Now
I hear good communication. I also want to hear when you need help, Elias, when you need help, ask for it. Okay? That's good communication too.
And we're gonna design this teepee so it can stand up straight.
Wait, no.
And we're gonna get. Now I'm getting.
Okay, this isn't working.
The group I was filming for the instructional video series was at the station that we call the architecture station. Improvisational architecture, and of course kids love to build forts. So we've provided bins that are bins the parents of the community actually made out of old pallets. And in those bins they find bamboo, sculpted wood, a whole range of eclectic materials that they can use to fabricate structures that they can get inside of many times. So it's like, you know, they call them often teepees, forts. And so this group was making choices about what they wanted to build and how they wanted to do it together. And I was asking them, because I was running a small video camera to capture their work, to say what they were doing as they worked. And then at some points we also stop and assess not only their design decisions, but how they're communicating, the language they're using, because we do want this to be a model for the other and sometimes younger students. That looks like more than decoration. It looks like it's going to actually stabilize your structure.
Yeah, it also stabilizes it just in case the string falls apart. This can also still stand up.
So it's big enough for Ryan
to tie it.
Because the triangle's steady, but
around
this
here.
bamboo's
tie it
not
right here.
steady.
And right now,
Now Rice is tying this to the back, so it'll be a little stable.
Now I'm gonna scoot it over, and I'm gonna scoot this right here.
kind of getting
So
Need help?
we can put the ladder, and we're gonna put one more little
kinda heavy.
like bamboo and stuff.
There you go.
Wait,
because so now I have this big, now this big stick, so it won't take really long to do this thing. So I'm gonna get it kind of big right here.
maybe we could put this right there and put that somewhere else.
Now we're gonna
okay, that's
flip
cool.
it over
It's kinda like
so
a
we can tie.
So that is our little door, and I'm gonna put this right here.
Wait,
I'm putting this lattice over here. And then it's like bird. And this part is kind of like birds.
No, we're gonna put that big one over here on here, cause so it's big enough to fall and do stuff bad.
Good teamwork.
Wait, put it like this.
On here.
now we're putting this big piece of wood right here.
It may actually balance. Yeah, so waterproof.
Is that really going to stay?
Yes.
Okay.
That's why we have a lot of material to kind of hold it. Because if we have more material, it'll be more steady, and it can actually stay on there and not fall off.
I just put a bucket right over here by this little piece of.
I just hit the pause. Let's circle up and have a little discussion of what we've done so far, what you guys have built so far, and how you've done it. So come over here, would you? Just kind of like take a knee, but not in the mud. Like we do in sports, we say, take a knee. Okay, so this is off for the moment. Great job so far. I've got some really good clips that I think we'll use for the instructional videos to show. I like the cooperative language I'm hearing. I like that you're asking each other for help when you need it.
We did say no.
I didn't hear anybody say no to each other's ideas. That's good cooperative language. So let's turn around and look at what you've got so far, because it's growing pretty fast right now. And as you're being designers of this, for one thing, I can tell that you are experienced TinkerYard builders, because what you're doing shows a certain kind of confidence, and that's what we want to show the other students in the other classes who don't get to come out and use the TinkerYard as much as you have. So you're being good, confident designers, collaborators, and I hear that in how you're talking and how you're moving with confidence from the bins, from the storage bins, and over to your work area. So right now, I want you to pause and assess what you've built without considering building onto it right away. Just circle around it and look at it with a critical eye and see how you might improve it, and then continue. Even talk to each other about that. Okay, hit the pause button again, guys. Hit the pause button. Good. So what you're doing now is real interesting to have on our instructional video, because we call this re-engineering. You have built, you have designed, and now you're editing your original ideas to make it more stable and to make it look the way you want it to look. So that re-engineering step happens a lot on the TinkerYard. It's always part of tinkering. When you're tinkering, you make a change and then you say, maybe I'm going to take part of that back and change it again. So this is a good part of your process to have on camera.
We saw that there was too much lattice, so we were like, we could take some.
Lattice?
Yeah, we could take some off, and we took
Okay.
some off.
Yep, that's good. That's good re-engineering and good design discussion.
We could kind of take some of this lattice off, so we could keep the door, so this could kind of be the door, because it's kind of a door
okay, so
straight.
let me make a suggestion. I kind of like the way it looks right now, and I challenged you and asked you a minute ago, can you still get inside it?
Yes.
And I heard yes, but now I'm wondering, it looks a little tight.
Take
How
like
many of you
5.
can still fit inside it?
Probably like one
See,
or two.
watch.
Show me. How about just show me?
Wait, not this
Show the
side.
camera. I'm going to get this running again.
Okay, only one person.
At a certain point, watching the students build, I find that they then start to edit their creation. And they start to subtract and not just add elements. So the language that I was offering them was to refer to this as re-engineering. And this is something that we see students on the TinkerYard doing constantly. They create, and then they step back and they make different choices, or a friend that's working with them suggests a different way of doing something. So they're re-engineering, they're making something that serves their purposes more closely. At one point I asked them, did they intend for everyone in their collaborative group to be able to get inside their structure? And they said yes, but then they discovered that they actually didn't fit. So then they started to reconfigure what they were building so that it could work that way.
Raise your hand if you are on the black border crew, the washing. It looks a lot better, and once it dries, we'll be ready to put it up. So give yourself a pat on the back. Thank you very much. Raise your hand if you are on my handles and hinges crew. Awesome. You guys did a really nice job today. Also, do you guys notice the yellow handles that are on the bench over there? Oh, yeah. They did a really nice job. Give yourselves a pat on the back. Excellent job. Excellent job. And we started adding the yellow crescents up at the top. It looks really nice. You guys did great work today. All right, so you should be facing forward, please, behind Ellis. And Nia, you can go ahead and take a front drive there. And yes. We will have a moment for you to wash your hands when you go inside. By one moment, that's literally what I mean. You have about 30 seconds to do that, and then I need you back in your seat, okay? And we'll get started inside, okay? Let's go. And please no hand dryers. I'll be out with some paper towels for you, okay?
It says filming.
Yes, yes.